Hey.
Welcome, everyone, to the very first episode of Gradient Descent. And since it's the very first episode, we'll spend a little bit of time talking about what it is, who we are. First of all, my name is Vishnu Vettrivel. I'm the founder and CTO of Wisecube AI. I've been practicing data and AI for a long time now, decades. And with me, I have my co-host, Alex Thomas. Alex, you want a quick intro?
Yeah, I'm Alex Thomas. I've been working on and off with Vishnu for like 13 years now, almost. I've been a software engineer / data scientist / data engineer. Most of our focus has been on NLP. I wrote a book for Spark NLP. I'm really excited to sit here to talk about AI, especially with LLMs and how much they completely changed the space of NLP.
On that note, I think you might be wondering, hey, why another podcast? And we felt like there's a lot of podcasts out there, even a lot of podcasts about AI, but it didn't feel like there was enough where AI practitioners were talking about the topics that were relevant in the industry, and we're really going deep on it. It was a lot of hey, here's some news bites and sound bites and stuff, but we wanted to do something where we would spend time on one topic per episode and just go really deep as practitioners to talk about how it affects not only the industry, but also, other practitioners and how they should be thinking about it. What are the, different angles to it. And so that's sort of why we started this podcast. And, so we are going to descend, if you will, into the topic. So having said that, I think one of the first things we want to talk about for this episode, at least, is, the thing that's really taken the AI world by storm in the last few weeks, DeepSeek, right? So for those of you who have been living under a rock, this is this Chinese company that, I want to say, Alex, was it around Christmas time, they announced this model that potentially had, the reasoning model, which was supposedly as good as, some of the cutting edge models that OpenAI and others have put out. With that, and it's sort of not only that, the claim was that they could actually train the model in a fraction of the cost it took to train OpenAI's model. And so that had huge implications and all that. But all right, with that said, let's get into it.
Yeah.
So I wanted to first talk about, before we set the stage about, DeepSeek and why it matters, maybe spend a little bit time talking about the status quo before then, right? Which is this whole idea, once again, a lot of people might be familiar with this concept of scaling laws, right? And so there's actually a paper put out, I think it was maybe 4 years ago or 5 years ago now, actually, where it talks about how large models, neural language models, that the loss of the scales to the power law within model size, data set size, and amount of compute, right? So the idea is the more data you have and the bigger amount of compute you can spend, and the larger the model size itself, that's how you reduce the loss of the model, which means that's how you make the model better, right? So Alex, I don't know, thoughts on just the scaling laws up until the point where DeepSeek and it's been largely sort of holding true to that point, is it right?
Yeah, I think there's two things come with scaling laws. One is the computational difficulty, and we're already starting to see debates about infrastructure and these sorts of new AIs and what they require. But there's also another thing, shortly before the DeepSeek new DeepSeek models came out, people were talking about peak data, basically that the best models for OpenAI or Anthropic or what have you were already getting essentially all the data that was reasonably accessible, and that we sort of hit the point where we weren't going to be able to just scale up the amount of data anymore. Now, of course, what that means is that you can still increase the number of parameters, but if you're not increasing the data with the number of your parameters, you're not going to really get like the big leaps in performance that we've seen from the previous iterations of the GPT model.
By the way, this idea of peak internet is always interesting to me, because what we're also starting to do is the AI models are now in the internet, and they're generating content with Gen AI models, right? And so now, I know you've talked about this whole idea of the dead internet, right? And so now you can almost like see where it's going. It's like, okay, if we've picked on the amount of like useful information that can be scraped by these models in the internet, and then now on top of that, the models are starting to like poison the well, so to speak, right? Now, literally, then like the amount of useful information start going down, right? And as a percentage of the total information. Anyway, I just wanted to sort of call that out. There's content. The danger of generating content so much easier is that, well, now everybody's going to do it. Which you think about, like the analogy for this would be like the invention of the email, right? Before the email, it was hard for people to communicate, effectively, and they write memos. But once email happened and email becomes so cheap and free, then the chance of abuse became, and then spam was, the dominant form of email, right? Like most emails were spam or phishing emails. Anyway, it was just interesting insight. So
I think that like there's always and will always be a ridiculous amount of low effort data being put out there on the internet. Now, before LLMs, if you tried to do that programmatically, generally it was like way low value. It was pretty easy to spot. It made grammatical errors, more specifically grammatical errors that made it so it's obvious it was AI. And the big thing with LLMs is that they're able to produce essentially fluent language. So that low effort content is going to be harder to distinguish, which means some of the low effort content that was done by humans beforehand is now automatable. There's this concern about like if these models are, training on their own output, that can lead to a degradation of performance. Now, that's not necessarily not everyone agrees on that, but I do think like there's a a concern that if a significant portion of the data that's being produced every day is switching from low effort human generated to low effort AI generated, then the valuable information in that data will actually begin to get old, because it's these models that are just like sort of regurgitating the same information.
Yeah. But it's true. I think we should probably do a whole episode on the dead internet and the peak internet. but coming back to this one, so coming back to DeepSeek, I wanted to sort of also talk about like, okay, so they announced the thing, huge market reaction, right? When people realize the impact of this, is like, oh my God, like does this mean scaling laws are no longer true? What does this mean for NVIDIA? What does this mean for OpenAI? What does this mean for US dominance in the space? There's all kinds of questions being raised in the market, and like, talking heads talking about this. NVIDIA had its biggest single day loss in its history. It still doesn't make, which is not even, it was a small percentage of their overall stock, market cap, but it's still $600 billion with a B. They lose in one day, which is probably the market cap of, many Fortune 500 companies put together. Just insane, right? Anyway, so everyone's like just doesn't know how to react to this, and then of course, famously, Satya Nadella puts out a tweet or something and says, "Hey, this is not, there's no reason to be alarmed by this. This is actually a good thing, because," and he claims this, he quotes this thing, Jevons Paradox, right? This is a sort of economists who came up with this paradox law, where like the price of a technology or some sort of process going down can actually lead to sort of latent demand coming up, and where more people are actually now wanting it. It's used for more use cases and actually helps drive up overall demand, right? And so he was sort of making this point, is like, hey, it's okay, we found this new way. that's only going to make other use cases possible where it was too sort of expensive to use AI, and this is going to help everybody, and whatever. And we'll talk more about that angle as well. But quick thoughts before we, I want to also get into like just talking about why is DeepSeek different, and like talk about some of the foundational architecture and things like that. But I don't know, quick thoughts on just the market reaction and like your overall take about DeepSeek, and we'll talk about it at the end as well. But yeah,
the idea of like the old story of like lemmings running off a cliff, turns out it's like mostly a myth. And what we should be saying now is tech investors. I think that there was a lot of everything is over for these companies and it's all doing this. No, really, like what DeepSeek did, like, is a major achievement, but like it also does sort of like move the community forward, and it gives a sustainable way for multiple companies to begin to continue improving their models, even if we have reached peak data. Because like, and to sort of like to segue into some of the details of what DeepSeek's doing, they wanted to use more reinforcement learning instead of supervised fine tuning. Now, what does that mean?
Yeah, but let's get into that. Let's talk about. So how did they do this? Like, what was, up until this point, transformers, like obviously LLMs have been around at this point for 2 years, 2+ years. People have been doing fine tuning. People have been using reinforcement learning. Maybe set the stage for how they train the model, what is foundational, and then what, and talk about that a little bit.
Yeah. So ultimately, the architecture of the model is the same as their previous the supervised fine-tuning ones, and they've been pursuing the sort of question of, can we get away from supervised fine-tuning? I think for like a year and a half, they've been pursuing that question, and like that's
and just to set the stage. So there's what are the options? Supervised fine-tuning versus what?
Versus reinforcement learning. Supervised fine-tuning is where you're giving the data that you're like extracting from the internet, and you're giving sort of like inputs and good outputs, or inputs and bad outputs. You're giving like labeled data to the model training. Classic.
The labeled data. So this is after the stage where you've scraped the internet, you've like tokenized them or whatever, and you've trained your, let's say you'll call your base transformer language model, right? And so now, as some of you people might realize, there was a second step where they would take this sort of base model, and then they would find either you could fine-tune it with supervised labels, so meaning that somebody actually go in and saying this is good, this is bad, and they come up with a data set, a golden data set, if you will, or label data set, and then use that to fine-tune the model. Or the other option was using this sort of RLHF, or reinforcement learning with human feedback, right? Mm-hmm. And that was sort of in fact, that was the original sort of like in the GPT paper, they talked about using RLHF, and so that was the original sort of default way where people were, let's say, fine-tuning large language models up until that point.
So the real thing we're looking at here is like, so if you look at what the LLM's doing, right, it's learning how to predict sequences, right? That's fundamentally what it's doing. And like, you can give it all the internet you want, but that's not necessarily going to help it with like the normal LLM use cases, right? So they have the second layer in order to train it for doing particular tasks or to respond in particular ways, right? And it's common, or it was common like before this paper, that phase was dominated by supervised fine tuning with some reinforcement learning. Yeah, the reinforcement learning is like, it's often with like a human feedback, but like you can also mix in the human feedback with a lot of sort of like generated interactions that will simulate that human feedback. The thing is, like, they had this DeepSeek V3, which is like was below like GPT-4, right? It did not perform as well. And so the question was, can we? That's like the base of that model. Like, okay, well, what do we do to like improve on that model? Normally, what people were doing is that you just take a lot more data, you do more supervised fine tuning, and that's how you improve the model. And every now and then you can
and that would be in line with the scaling laws, right? Just
Yeah.
to bring it back to the scaling
Yeah.
laws. It's like, okay, hey, more data equals better model.
Yeah.
That's what the scaling laws say, right? Like, and yeah, so that would not have been groundbreaking or revolutionary.
Yeah.
But go ahead. Yeah.
And it really it's a second phase that's very sort of sensitive to the idea of like, oh, are you getting relevant data? Are you getting are you getting data that's still timely? Because if you look like the basic parameters of the model, it's learning these sequences, and the basic like sequence of characters that make up Python code or make up a cake recipe. Like those sequences of characters does not change much over time, but the specific responses it generates to like time sensitive things that can change. So that's where you need to like keep things up to date. Like I said with the scaling law, the problem is that
and let me just dig into that a little bit.
Yeah.
So because what you're saying, which the model's going to output whatever it's going to output with a different set of likelihoods or probabilities. And that's we're still talking about the base transformer model, right? And then really where the magic of like these language models in practice right now, like GPT and others, is that, hey, I could generate all of these possible sequence of things, but only a few of these actually make sense to like what question or task I was asked to do, or in what context it was given. And that's why that piece is so important, because once again, it's the brain analogy. I could be saying lots of things. Somebody asked me a question that could be like 10 things that come to my mind, and we're doing this without even thinking about it, is like we're sort of narrowing down the responses to what is most relevant in the context, in the conversation, in the environment that we're in, and we're sort of picking the right response to what was asked of us, right? And that is almost a second level function that we all do, right? We sort of filter ourselves and pick the right thing to say, right? Like if we're on a podcast episode being recorded, I'm not going to say certain things because I know I'm being recorded, right? And so that's where the intelligence really comes in. It's right. And this is why it's so important for the language model to be able to do this. Good, yeah.
Yeah, and I think and this is where I think that the move to reinforcement learning is really broadly helpful to the community in moving this forward, because it potentially solves two things. It solves this limitation on data, because you can take this human feedback and the simulated human feedback, and you can continue to train the data, but you need to be able to have this like improvement mostly rely on the reinforcement learning. It also does another thing. So there's a paper by Chenjichu and others called SFT Memorizes Reinforcement Learning Generalizes, a comparative study of foundational model post-training. And
that's a bad thing. I'm sure
memorization is bad, right? So when we have the models that regurgitate things. So a lot of the more famous examples actually come from the image generation, where like someone says, like, oh, make me a picture of this truck, and it happens to like copy almost identically a picture on like the Ford website or something, right? That's regurgitation. That's from memorization. And that is something that supervised fine tuning it does. And so like that's not necessarily a bad thing, right? Because you do want it to be able to understand formats, to how to turn things in the right format. But reinforcement learning helps the model generalize its responses, so that when you ask it to write a Python function, it's
just a brief aside. Sorry, Alex, 1 second. Yeah, I'm sure everybody knows what reinforcement learning is at this point, at least everybody in our audience. But just as a brief aside, it's this whole branch that it's almost was separate from your traditional machine learning, statistical machine learning, and it was mostly focused on learning policies by setting up your system in terms of, hey, what's my objective? Having some sort of a goal, having some sort of reward system, and then letting the system sort of learn the most optimal policy to maximize a specific reward, right? And Sutton was obviously, he was the, for those of you who don't know, sort of the grandfather of the space. Sutton. He's actually a professor from I think I want to say Toronto, and he was sort of the I wouldn't say founder, but he was definitely one of the biggest proponents of reinforcement learning. Like the original paper on his paper on policy learning and whatnot are still like the foundations of this whole branch of AI. And for those of you interested, definitely go look him up. And there's an excellent course on Coursera on reinforcement learning as well. But anyway, so I wanted to just brief aside to RL, and really RL came into being because it was sort of on its own, doing its own thing, and it was used in sort of control system mechanisms and things like that, sort of outside of the mainstream of machine learning and AI. And it was not until GPT where it sort of came into the mainstream in a big way.
Yeah.
Go ahead. Sorry.
And that comes from an innovation about like how to incorporate it into training, because like we're used to, consider the name of our podcast, gradient descent, and neural network models are trained with that using like backpropagation, right? So as like you're trying to train a sequence, so you're training things, and basically as it makes right or wrong things, that gives a signal that then is then backpropagated through the network, updating all the weights. But if your response is sort of a qualitative, more general response to the entire action, so the entire sequence you're putting out, that's harder to put in terms of that. And what GPT and what the was done with reinforcement learning coming to LLMs was basically developing techniques for using reinforcement learning to update these parameters, right? So
you're saying it's just a technique instead of backprop. I'm going to use RL to find like the ideal policy. Yeah. Well, in this case, it's not the policy. I'm learning a bunch of weights, I'm assuming, right? Or
you're updating the model using the feedback from reinforcement learning, which is like, it's different than just like the sort of gradient descent backpropagation that we're used to, where it's sort of like, did you get the correctly labeled thing or not?
Right. And I think, by the way, I like techniques where it doesn't depend on like a differentiable function. I'm getting a little bit in the weeds here, but I like optimization techniques that don't assume a particular kind of function and constraints around it, right? I'll give you an example, right? Like, everyone talks about, gradient descent, obviously, famously, you need to have a loss function that's differentiable and do all of that stuff. But then there are techniques like particle swarm optimization, like those kinds of things where I don't need to know, like I don't even care what kind of loss function and how it looks like, is it differentiable or not. All I need is like, hey, some sort of an estimation function, some sort of a reward function. Then I can start doing things, which sort of what like RL does too, which is like it doesn't make any assumptions about the underlying loss function itself, right? Is that?
Yeah, and I think that you bring up an excellent point. Like, if you look at the previous sort of like, the previous new hotness and NLP, it was like BERT models and stuff like that. And like those, because it's still using that approach, really what that was about contriving a task that would learn good parameters for general use, right? So the task like BERT was like masking tokens and getting it to predict it based off context. And there were obviously developments on that where they came up with like different variations or more sophisticated tasks or like that to train newer models. But with reinforcement learning, it allows you to connect to like the actual tasks you're interested in. And like in linguistics, like it's interesting. Like as we improve in NLP, the parallels in the realm of linguistics get clearer. We're really talking about here in linguistics is sort of the pragmatics, which is like, why are you saying what you say? So like if I say it's pretty cold in here, do we need the window open? Syntactically, that's a question. Pragmatically, I'm asking you to close the window, right? And so as we're developing these ways of like judging tasks, we're able to train these models on tasks that humans don't need to contrive fake tasks that it can simulate, right? We can actually train it to generate code. We can actually train it to, write an email for you. right? So the thing with reinforcement learning, why this is so good is that we talk about the scaling laws, we talk about the peak data. It allows us to improve by just improving the reinforcement learning regimens that we have. And there's another really, I think, big thing from it is that one of the things that they did is that they have this like big model from the reinforcement learning. And what it is like, you have like the base model from DeepSeek v3. They did some initial stuff. This is for not R10, this is for R1. With R1, which was the better performing one, they do some limited supervised fine tuning and then reinforcement learning. And what that solved was with R0, with R10, they had a problem of its output was not very good. It would sometimes mix languages. It would respond in like English and Chinese. Sometimes it would ignore the sort of the format it was instructed to use. And the problem with that is that one was pure reinforcement learning. And reinforcement learning is very bad at learning formatting. It doesn't memorize. When you want a model to learn formatting, you need it to memorize it. You need it to do, you can't sort of return JSON. You need to return valid JSON. So, they do this R1 where they do a little supervised fine tuning so it can get good at formats, and then reinforcement learning. Then they take this big model and they have it generate data for supervised fine tuning smaller models. So they did this with Quen and with Llama models.
By the way, there is some, I want to just pause on that, because afterwards there was some controversy around this particular step in the training process. And I think it was OpenAI, Sam Altman came out and said something like, hey, you guys might have used our models to generate the data that you're talking about required for this step, right? And by the way, is this what they call distillation, or is that a different step?
What I'm talking about is the distillation, where they take their they take the R1 and use it to generate data for training Quen.
Right, and so this whole distillation step in the training, there's some controversy around it, right? And I don't know. Now, of course, in the paper they talk about using open source models for this step, right? But there's some allegations out there that saying, hey, they might have used OpenAI to actually generate the data. And so in some ways, they're sort of building upon all of the work that was done by OpenAI and spending all these hundreds of millions of dollars. So, and then the question was raised is like, hey, so is this a violation of scaling laws if you're actually using a model that was built to use that still obeys scaling laws?
Yeah. I think there's the sort of scientific question, and there's also a legal question. Neither of us are qualified to give the legal question and answer.
Right, but at least the scientific, the question about scaling laws, does this, if distillation is such a big step in the training of DeepSeek, and
it's not for the training of DeepSeek distillation. Distillation is once they have their DeepSeek model,
right?
They then train the Quen and Llama models using data generated from DeepSeek ostensibly. And yes, there's accusations that either that data was maybe not generated by DeepSeek, or that the data set that was used for training DeepSeek itself may have been taken or is based off of proprietary stuff from OpenAI. Now, I don't know necessarily how we would check that. I mean, it is. It seems like they, since they open sourced R1, this is something that could potentially be checked by someone in the community who has spare few tens of millions of dollars to see if, can you actually achieve this?
By the way, on that note, we should mention that soon after DeepSeek came out, and it was maybe a couple of weeks ago, I want to say a month ago, I can't remember now, but there was this team from Berkeley that was able to recreate, the DeepSeek sort of recipe, if you will, a training recipe, and then they claim they did it with less than $500 or something like that, right? And so it looks like at least that sort of set of steps and the recipe for training DeepSeek-like models is being replicated by other teams in other parts of the world, right? And so this whole idea of being able to train a really good large language model and the cost of it coming down seems to be, at least so far, sticking, right? Which it seems to be replicated, seems to be that we have entered a new sort of world, a paradigm where it's become much more efficient and less expensive to train these really large language models.
Yeah, and I think though that, if I recall, that was them replicating training R1 off of DeepSeek V3. I don't think that they trained from scratch V3.
Not from scratch, but they were using either an existing LLM, R1 or something else.
Because you still have the issue of in order to be so fluent in returning these sequences correctly, you still do need that huge amount of data from the internet, so it can learn those sequences. But that doesn't cut it anymore, right? DeepSeek V3, if you look at it in the DeepSeek paper, it performs significantly worse than the GPT ones, right? And
right.
So it's
and speaking of that, it's not like DeepSeek is better at everything, right? In fact, you've looked into this. There's certain papers that actually looked into this where they were looking at how effective it is, how safe it is, bias and things like that. Just share some thoughts on that. What are the findings around that? It's not clearly not better at everything. There are some downsides to it, right? So
so there was a paper done by Aitor Ariadne called O3 Mini versus DeepSeek R1, which one is safer. And what they found is that DeepSeek R1 was 10 times more likely to return a toxic answer, giving a prompt that is made to produce a toxic answer. Now, a little bit this may be because we're not comparing apples to apples here, because what they conclude in that paper is that OpenAI has a bunch of safety things built around the model, right, to avoid these toxic things. So, if it detects a question that's inherently toxic, it can actually intervene and block that question and just give a canned response. Whereas it looks like if you're running the DeepSeek on your own, right, you don't get those guardrails for free. There is also another thing. There's been these, obviously, because China's involved, there's a whole censorship question involved, and it's been pretty easy to actually break through some of the censorship with DeepSeek. So it's whenever you have something that's just a model, it's not necessarily going to be as safe. So the safety, you can only do so much in the training data and the training.
Right.
Guarantee safety.
Right.
But as you said, with I think the real question here is for these existing benchmarks, it does pretty well. Maybe it's just a little bit below some of the new GPT models. The real question is there should be these differences from the reinforcement learning. Can we see if it is actually less likely to regurgitate things? A lot of the existing data sets out there, at least from my look, they're not really good at determining this about whether it's returning memorized answers or not. But that's always.
But on that point, maybe we can just try to talk about and summarize next steps around clear and talk about hey, so what is next for not just DeepSeek but this whole new way of training LLMs? Using distillation, using reinforcement learning more than supervised fine tuning, and what is the trend broadly around it? And then let's talk about that, and then also maybe we some ideas on or tips around if you're considering using DeepSeek, what would be some of the things you should think about, right?
So I would say if I was talking with someone and they were considering using DeepSeek. I think one of the ways that, because you were talking before about this, was Jevons Paradox.
Mm-hmm.
One of these trade-offs is that it broadens the market. The distillation of these models is actually one of the ways it can really broaden the market. Because now maybe people are working on something that they don't want to send out to an externally hosted model from like OpenAI or Anthropic, and maybe they want to just like make their own host or their own model. Well, that's kind of hard to do with like an 800 billion parameter, monster. But this distillation seems to actually perform pretty well given its size, at least according to the DeepSeek paper. So, like, my recommendation would be like, can you use one of these distilled models to replace your OpenAI or your Claude or your GPT or your Claude? I think as far as for like the research in the community, I think understanding and like really drilling deep on this issue of memorization and regurgitation is important, because a week or two ago there was another judge's decision that said stuff that's just generated by an LLM is not trademarkable or copyrightable. Like, you need to demonstrate significant work into it. It can't just be from an LLM. And if you have that problem where stuff from an LLM is not inherently IP that you can protect, there needs to be some work in the showing that this is not just sort of remixing what already there. There is actually intellectual property from like designing your prompts and stuff like that. I think that's a very important next step. And then it's sort of interesting to see like where OpenAI responds to this, right? Because essentially, like, right now, like it's their response to make. Like, they're coming out with with 4.5 is already sort of like in like a beta sort of right now. And how are they going to take the next step? And do these like new training techniques? Does it mean can there be now a wider set of companies that are offering these large models? That they take one of those very large llama models. Can they build like really good performance off of like reinforcement learning on one of the open source large models? So I think that's why I think is sort of like coming up next on this.
Yeah, no, I think it's exciting for sure. I think that we've definitely, one thing we can all agree on is that this is definitely a watershed moment for large language models in general, because it makes it so much more affordable for people to train pretty good models. And they're still big models, right? We didn't talk about this. So there's still giant models. Running them locally is still going to be pretty expensive because it's going to require a lot of RAM and like the GPU capabilities to even the inferencing side of it. We were just talking all of this, by the way. I should just preface everything by saying all of what we're talked about with DeepSeek and the whole breakthroughs are related to the training of the model, right? Where we went from like hundreds of millions of dollars to now like tens of millions of dollars and maybe even less. But the inferencing side hasn't really improved as significantly yet. It's still very large models. Maybe there's a whole episode we should do about mixture of experts and like, that whole thing and different kinds of LLM models. But that is not what DeepSeek really revolutionized, right? And so, but it's still a big watershed moment, right? For the training side. And it's pretty exciting to see that this space is still surprising us and constantly, and new innovations are being put out, at a constant clip. One
of the things I'm actually excited for is with this distillation, is that like what are going to be like the domain specific distillations? Like right now, like they took their R1 and they did like a distillation of it. Like, are people going to do like a biomedical distilled one from this? Or are they going to do a finance distilled one? Like, how is that going to improve these domain specific models?
Look, I think these will be excellent topics for us to dive into or descend into in the coming episodes, any one of these. But I wanted to also thank, if you've been listening so far, thank you for that one person, and also we'll put all the links to all the papers we talked about in the show notes, and would love to hear about other episode ideas, that you think we should sort of go deep on. Please put it in the comment section of the platform of your choice, and we'll try to definitely get access to all of those. But looking forward to doing more of these, and just doing a deep dive and a gradient descent, if you will, into some of these topics in the coming weeks and months. So with that, I want to thank Alex for having this fun and very informative conversation, and thank the audience for sticking with us so far, and hopefully see you around. Thanks, everyone.